Direction of change. The concept of direction and change revolves around the potential paths an entity can take from its present state. Every entity exists within a framework of past and future states, with the present moment defined as state 0, the past as state -1, and the future as state +1. At state 0, the entity has a multitude of potential directions it could move towards. The direction of change can be seen as a vector emanating from a specific point, with numerous possibilities within a given space. In a three-dimensional context, there are approximately 41,253 square degrees of possible directional change. This vast range of possibilities underscores the complexity of change and the variety of outcomes that can emerge from a single moment. For simplicity, we can consider three primary possibilities: state 0, existence; state +1, evolution or progression; and state -1, reversal, a rare but possible outcome, illustrating the different trajectories change can take. Directed change refers to the intentional or guided nature of change in a specific direction. It implies a purposeful or deliberate steering of change towards a desired outcome or goal. Directed change can be seen in various contexts, such as engineering designs aimed at optimizing efficiency, evolutionary adaptations driven by environmental pressures, or strategic decisions guiding organizational change. This concept emphasizes the importance of intentionality and planning in shaping the direction of change to achieve the desired results. The direction of the change in an entity is usually determined by the environment or the constraints it is in. If an entity warms up, it is because of the increase in temperature in its surroundings. Periodicity, such as day-night cycles, can cause the reversal of temperatures. During the day, the land warms up, and during the night, it cools down. This is an example of reverse direction, 0 to 9 is 1. If an entity degrades, it is because of physical or chemical forces imposed by its environment. Only in the living systems and modern artificial systems could the entity decide or at least have a say or intention on how it can choose to change. In living systems, the entity could also be a factor in deciding the direction of the change. We shiver to increase our body temperature. We move away from cold places. We cover up to shield ourselves from the low temperatures. To varying degrees, most animals have a way of dictating or regulating changes in themselves. Life at the molecular level exemplifies dynamism, characterized by the ability of molecules to undergo reversible transformations. Biomolecules in living systems can change and return to their original states, balancing change and stability. For example, double-stranded DNA can separate into two single strands and later reassemble into its original double helix, a crucial reversible process for replication. Similarly, proteins adopt multiple conformations, shifting structures to meet functional demands. These transformations often exhibit a direction of change, such as single DNA strands reverting to a double helix, or proteins adjusting to specific conformations in response to environmental conditions. That means there's change in all parts of our body all the time. The formula for change, delta equals magnitude times level, direction times duration. The magnitude of change is proportional to the total force applied, internal and external, and the difference between the entity's thermodynamic state and its environment, akin to principles in physics. Level refers to the strata of emergence, with lower strata representing foundational strata and higher strata denoting emergent properties dependent on underlying emergent property. The lower strata have the highest value, high impact, while the higher strata have the lowest value, low impact. Direction, ranging from -1, regression, to +1, transformation, captures the trajectory of change, where -1 reflects a return to a previous state and +1 indicates a leap to an entirely new, unknown state. The concept of 0 as the current state emphasizes equilibrium. Finally, duration adds the temporal element, indicating the persistence of change. The interplay of these factors determines the scope, impact, and sustainability of change across systems, offering a comprehensive model for analyzing transformative processes.